Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 8C. I am Pranjal Banage, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday, 9 July 2026, in Goa, India, and the virtual event is being held through Zoom from 9 to 11 July 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for their presentations and 2 minutes for question and answers. In 8 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Now, before we start our session, I'd like to introduce our session chair for this session, Dr. Srinivasu Gokulu. He is a professor and head of department at Vardhaman College of Engineering, Telangana, India, bringing over 19 years of distinguished academic experience. His academic and research work centers on deep learning, natural language processing, machine learning, and data mining. A renowned author and researcher in the field of intelligent systems, he has contributed extensively to advancing modern AI technologies through his publications, mentorship, and leadership in academia. Sir, I'd like to invite you to give a few opening remarks.
Thank you very much for giving me this wonderful opportunity. This is my fourth time continuously in the pipeline serving as a session chair. I am more privileged and honored, again taking pride of this prestigious 11th International Conference on Information and Communication Technology for Sustainable Development. Looking forward to give the best of my knowledge in terms of suggestions to the authors, so who would like to present their novelty research in this conference. Thank you very much.
Thank you so much, sir. Now we'll be officially starting with the session. I'd like to invite our first presenter, Durga, to present her paper on a comprehensive review of text watermarking techniques. You may start with your presentation.
Sure. Thank you, ma'am. Am I audible?
Yes, ma'am, you're audible.
Hi, ma'am. Whether my screen is visible?
Yes, Durga, your screen is visible.
Okay. Sorry for the delay, ma'am. Good morning, everyone. I am Durga. I'll be presenting a comprehensive review of text watermarking techniques. I'm carried this project under the guidance of Dr. K.B. Sundarakumar, sir, Associate Professor, SNU, Chennai. In this presentation, I will review the major watermarking techniques discussed in the literature, discusses the strengths and limitations, then the various attacks involved, and highlights the research objective towards the evolving AI field. So to begin with, sorry. So to begin with, let me briefly outline the today's presentation. The presentation is categorized into 7 sections. First is the motivation behind the evolving watermarking techniques, then the overall workflow, then the embedding approaches. Here, 3 major embedding approaches: rule-based, inference time-based, and the deep learn and the neural based watermarking. Next is the detection and extraction, and third is the watermarking attack. Next, I will be covering the attacks involved in watermarks. Then the most important is the evaluation metrics, and finally I conclude and the conclusion and the future direction. So let's first understand why watermarking has become an important research problem. Ultimately, the what text watermarking produces the rapid evolving of large language models produces contents like report articles, research summarization, and even the software documentations that are indivisible from human writings, that are almost so in order to distinguish, and also AI, fields of in the field of AI, there are various risks happening, that is misinformations, fake news, then plagiarism, many fraudulent contents has been generated. So in order to the major solution to avoid this comes the watermarking. The watermarking embeds a hidden imperceptible signal into the text in order to verify its owner or ownership, authentication, and verify its origin. So this should be imperceptible to human, that is and can be verifiable by using algorithms. So altering even a single, the watermarking in text is bit challenging, because not as easy as watermarking used in audio as well as images, because altering even a small word can change the text meaning. Text the meaning may even remove the watermarks. So, so ultimately, the goal of text watermarking is to provide a reliable mechanism for AI content attribution without compromising the quality or reliability of the generated text. So, next important is the what makes a good watermark. So, it should be invisible to readers. That is, the watermark present should not affect the grammar or um, readability or the content generation. It should not change the meaning. Next is the second one is the robustness to text modification, where it should the deduction should the direction of watermark should be should not be as easy. It should protect the text, that is even for small modification should not remove the watermark. Third one is the security against forgery and removal. Some attacks like in order to avoid from the attacks like spoofing and scrubbing, this should the the embedded watermark should be enough to against this spoofing and scrubbing. And fourth one is the capacity, that is the enough information should be capable of embedding watermark in order to verify it may be the ownership identifier or the any signatures, etc. And last final one is the reliably detectable. So watermark should be reliably detectable, and it should not be false positive or false negative. And the performance trade-off exists among these five categories. So if the system has more robustness and capacity, then obviously the imperceptibility and the security may affect. So this is so before discussing the major categories of embedding techniques, first let me show you the end-to-end workflow. So input may be a PDF or a prompt or a report. Along with that, the signature to be embedded is the input. This undergoes following embeddings like rule-based, inference time-based, and neural-based. So once the watermark is embedded, the watermark text is distributed over the network. Then it is undergone to various attacks, paraphrasing, summarization. After that, the watermark detection, even if necessary, watermark extraction takes place. So first, let us see what are all the watermark embedding techniques. So three major embedding approaches are used here. First one is a rule-based, second one is the inference time, and third one is the deep learning based. So, okay, first is the rule-based watermarking. Uh, the first category is the rule-based, and it is the earliest approach for the embedding techniques. Here, this embeds the information by applying predefined linguistics or formatting rules such as synonym substitution, punctuation changes, sentence structures, or linguistic patterns. One of the approach involved is the data mining techniques are used to identify the hidden attributes that itself acts as a watermark. Using itself act as a watermark. Using this, the watermark can be embedded. This helps to protect the document in local and cloud environments. And next representative approach is the combined approach of zero watermarking and natural language processing. This analyzes the linguistic characteristics of the document. Here, the Markov model is used to extract the distinctive text features that itself acts as a watermark key. This is a very simple to implement, interpretable. Here, there is no training overhead, and the computational cost is very minimal. But this method is very much brittle to paraphrasing. Uh, Even a small change in the word or may affect the meaning of the text in a larger way. Next important method is the inference time-based watermarking. This is most widely adopted approach for modern large language models. Unlike rule-based watermarking, here the watermark is embedded during the text generation without modifying or retraining the model. At every generation steps, the model predicts many next words. In this method, using a secret key, the vocabulary is divided into two major groups, red group as well as green group. And here, based on the bias value is selected that helps to making the slightly more likely to select the green tokens. Since the bias is very small, the generated text remains fluent and natural, and the readers cannot distinguish between watermarked and non-watermarked.
I'm
So,
so sorry to interrupt, Durga, but I'd request you to conclude your presentation now.
okay. So here, this is the major inference time watermarking happens. The vocabulary is divided into green and red list. Next is the tokens. Here we are selecting more green tokens so that so if on the deduction side, if the selected green token is higher, then it is likely to be understood that watermarked. So next is the deep learning based watermarking. Here, this is a costly process where the watermark is directly implemented in the neural networks. Here, the message encoder learns to hide the secret code in the token stream. Next, the watermark output And third one is the decoder part that recovers the binary signature. Uh, then the signature can be recovered. And similarly, the diffusion latent watermark, where the embeddings latent space, the text is embedded. This undergoes a few forward diffusion, then the reverse diffusion. Finally, the watermark can be recovered. The deduction extraction, after the watermark has been generated, the identification part helps to identify whether the watermark is present, and the extraction part, if needed, the watermark can be extracted. So the important aspect is that the watermark deduction is controlling the false positive rate. That is, the threshold should be maintained in such a way to balance to minimize the false positive rate. So most important is the watermark stealing attacks. So here, majorly these techniques, what we have discussed before, should mainly bypass these two basic attacks like spoofing and scrubbing. So model should be enough to attack to face these two attacks. Here, mostly the inference time-based watermarking schema or almost vulnerable to these attacks. So these are the stealing. Here, watermark stealing is major happening by continuously we are querying to the API model, so that with the help of that, the attacker tries to learn the patterns involved in watermarking. So for about less than $50, the success rate or 80% of the success rate is attained. So this should be avoided. So countermeasures, these are all the countermeasures taken to control these attacks. So next is the most important is the evaluation metrics. So these are all the evaluation metrics for the betterment of the watermark. And four main metrics involved are watermark extraction rate, imperceptibility, robustness, and security. And these are all the comparison between the approaches and the matrices. Conclusion, let me conclude. This is the is essential for responsible AI development and content attribution, plagiarism reduction, disinformation mitigation. So three major paradigm has been explained. Here, the watermark stealing attack demonstrates that many existing statistical watermark schemes remains vulnerable to spoofing and watermark removal, highlights the need for stronger security mechanism. So evaluation should consider watermark extraction accuracy, imperceptibility, robustness, and no single metric is sufficient to access all these performance. So finally, the future direction. In order, uh, so uh, in order to make the system more robust, so we need to consider the more efficient adversarial watermarking to be introduced, like GAN based, which learns to implement the watermark. It's very more resistant to spoofing, paraphrasing, and watermark stealing. And next, we are planning to implement the attack-aware training frameworks, where the training has been done with various attacks and paraphrases, so in the real world it can able to withstand those attacks. And next is a cryptographically secure watermarking, which
I'm
provides an
sorry, Durga, but I'll have to stop you. We've gone way over time. You have taken over 15 minutes.
okay, ma'am.
I'd like to ask the session chair if he has any questions for her.
Sure, ma'am. Any questions?
Yes, thank you, Durga, for your novel article presentation. Um, Before going for the questionnaire, did you come across any real-time typical application that where exactly your methodology can be applied?
Um, yes, sir. Actually, real world, even for coding, if we consider the assignments, many are student assignments. I came across that many of the content came from the AI generated. So, what I wanted to is to identify. So, with the help of watermarks, we can identify that it is from the AI generated content.
Okay, for that, there are various humanized tools available where even it can be caught.
Yes. In the company side, if the company data's may get leaked, so in that at that point of time, the watermark is present. So with that, we can track the data using this application.
Are you going to provide any novelty through watermarking?
Yes, sir.
Or
That is the
are you
main
going to
objective.
detect whether the text is copied or a genuine? So what exactly you are addressing?
Sir, using watermark, I wanted to first objective is to implement the most robust watermarking application. So that is we are trying to implement our work using adversarial watermarking, that is GAN based watermarking. So that is the
Okay.
first objective. Second one is that we are planning to create ownership information as a watermark, so that if my content got leaked or somewhere somebody some other else are using my content, so that I can able to track. So that is the second objective.
Okay. So have you tested your objective one?
Objective, yeah, it's in progress, sir. Almost I am about to finish.
Okay. So algorithm that whatever you have listed out, those algorithms are being used to implement the objective one, correct?
Yeah, sir. This is just a review paper, so I have
Ah,
done.
I got your point, but even the algorithms that whatever you have listed out, probably they are not sufficient to take out your objective completely. They are contributing very partial thing. So on
Yes,
top
sir.
of them, you are supposed to work for the next level of algorithms where you can take those help and get it finished.
Yeah, sure, sir. That is right. So
Okay.
I'm using GAN based. Since GAN based is, we have faced many challenges using the GAN based applications where
True.
so instead of balancing those things, we are using some other encoders also into the picture, and we are implementing.
Okay. Thank you.
Sure. Thank you, sir. Thank you very
I'm
much.
done.
Thank you so much, Durga,
Thank you,
for
ma'am.
your wonderful presentation.
Thank you.
We'll be moving forward. Before moving ahead, I'd like to raise a gentle reminder to all the participants to adhere to the time limitations of the session. I'll be inviting Kavita Bhosle to present her paper on an efficient multi-input CNN framework for feature extraction and crop classification from hyperspectral data. You may start your presentation.
Yes, ma'am. Definitely. Shall I share my screen?
Yes, ma'am.
Is it visible?
Yes, ma'am, your screen is visible.
Good afternoon, everyone. I am Kavita Bhosle from Maharashtra Institute of Technology, Chhatrapati Sambhaji Nagar. Today, I am presenting our research work titled An Efficient Multi-Input CNN Framework for Feature Extraction and Crop Classification from Hyperspectral Data.
Excuse
This
me,
work
ma'am.
has been carried out in collaboration.
Excuse me, ma'am. We can only see your Zoom
Yes, ma'am.
screen. We can't see your presentation yet.
Okay, 1 minute. Now, is it visible?
No, ma'am. We still see
Yes,
the
ma'am.
Zoom screen.
One minute. Ma'am, is it visible?
Yes, ma'am. Your screen is visible.
Shall I start now?
Uh, but it's a blank screen, ma'am.
Blank screen.
I can only see the Zoom screen. You'll have to share your presentation screen. Ma'am, if you're having trouble in sharing your screen, you can send your presentation in the chat box. I can share it on your behalf.
1 minute, 1 minute, ma'am. My partner will share. Is it okay?
Okay. Yes, ma'am, sure.
Bhakti, ma'am. Can you give her rights to share?
Ma'am, if you stop sharing, she'll automatically be able to share.
Okay. Okay. Yes.
Okay, ma'am.
Shall I start?
Uh,
One.
the screen is not visible yet. Okay, ma'am, I can see the screen. Please start with your presentation.
I am Kavita Bhosle from MIT, Chhatrapati Sambhaji Nagar. Today I am presenting my paper. This work has been carried out in collaboration with Ms. Bhakti and Mr. Atharva. The objective of this research is to improve crop classification accuracy using hyperspectral remote sensing images by proposing a novel multi-input convolutional neural network architecture. These are the contents I am going to present. Remote sensing is the science of collecting information about Earth's surface without making physical contact. Satellites capture reflected electromagnetic radiation from different objects. So every material such as vegetation, soil, rocks, water reflects light differently. So by analyzing these reflections, we can identify crop types, monitor agriculture, detect diseases, and manage natural resources effectively. Now this is my next slide, process of remote sensing. In short, I will describe. This slide illustrates the complete remote sensing process. Energy from the sun interacts with the Earth's surface. The reflected energy is captured by satellite sensors. The collected images are transmitted to ground stations, processed, and finally analyzed for applications such as land use mapping, crop monitoring, environmental assessment, and disaster management. Now literature survey. So we reviewed several recent studies on hyperspectral image classification. Researchers have applied methods such as PCA, SVM, random forest, autoencoder, and different CNN architecture. Most studies demonstrate that deep learning significantly improves classification accuracy. However, existing approaches generally rely only on spectral information and often ignores vegetation indices containing valuable agriculture information. So this limitation motivated us to develop a multi-input CNN that combines spectral information with vegetation indices for improved crop classification. Why hyperspectral? So hyperspectral imaging records hundreds of narrow spectral bands. Unlike RGB images, hyperspectral images capture detailed spectral signatures of every material. This enables us to detect material, identify crop types, quantify vegetation characteristics, distinguish healthy and unhealthy plants, and classify land cover with much higher precision. So that's why hyperspectral imagery is extremely useful in precision agriculture. Now this slide shows an example of hyperspectral data. Each pixel contains a complete spectral signature instead of only RGB values. Instead of that, if you use multispectral data, it is not showing minute details of crop. Now about data set. For experimentation, we use EVO1 Hyperion hyperspectral satellite data obtained from USGS Earth Explorer. The image contains 242 spectral bands, from which 155 informative bands were selected after removing noisy bands. The spatial resolution is 30 meter, while the spectral resolution is 10 nanometer. Our study area is Waregaon village in Chhatrapati Sambhajinagar district, Maharashtra. This slide shows the geographical location of study area along with hyperspectral image captured by Hyperion sensor. So this circled area is my study area. The selected agriculture region contains multiple crop types, making it suitable for evaluating classification performance. Ground truth. Ground truth samples were collected for 4 classes: cotton, mulberry, sugarcane, and rock. A total of 855 labeled samples were used for training and testing the proposed model. Now, tools used. So before training the model, several pre-processing steps were performed. Atmospheric correction is required, was carried out using Quack algorithm. Segmentation and vegetation index extracted were performed using NV software. And finally, the proposed CNN model were implemented in Python using Keras deep learning library. Now about PCA. Hyperspectral images contain hundreds of highly correlated spectral bands. So many of these bands carry redundant information. So therefore, principal component analysis was applied to reduce dimensionality while preserving maximum variance. The graph illustrates cumulative explained variance. Only the significant principal components are retained, reducing computational complexity and improving classification efficiency. Now about CNN architecture. So we develop and optimize convolutional neural network. The CNN consists of convolution layer followed by max pooling layer. For dimensionality reduction, I used max pooling layer, then flattening, fully connected layer, and finally a softmax output layer for multi-class classification. So I used ReLU activation was used because it accelerates convergence and reduces the vanishing gradient problem. The proposed CNN contains approximately 5.46 lakh training parameters. I have used optimized CNN. So several experimentation cases were evaluated by varying optimization. So after extensive experiment, ADAM optimizer with ReLU activation and 2x2 filter achieved the best performance. So I have selected as optimized CNN. Then propose multi-input CNN. So this is my proposed multi-input CNN method. The key contribution of our work is the proposed multi-input CNN. Instead of using only hyperspectral images, the model receives 2 independent inputs. The first input is complete hyperspectral image. The second input consists of 4 vegetation indices. So I have used NDVI, simple ratio, red edge position, and water band index. So combining these 4 indices given as second input, these indices provide complementary information regarding vegetation health, chlorophyll concentration, and water content. Both inputs are processed simultaneously and fuse within the CNN, allowing the model to learn features and improve classification accuracy. So this is my architecture where 2 inputs are provided. Next slide. So this algorithm I have used. So this slide summarizes the proposed algorithm. Each input passes through convolution layer independently. Extracted feature maps are combined, flattened, and pass through fully connected layer. Finally, the softmax layer predicts the probability of each crop class. The class with the highest probability is selected as final output. And then evaluation matrices I have used, confusion matrix, to evaluate classification performance. We first generated the confusion matrix. From the confusion matrix, we computed precision, recall, F1 score, overall accuracy, specifically, and kappa coefficient. These metrics provide a comprehensive evaluation of model performance.
Sorry to interrupt, ma'am, but I'd request you to conclude your presentation.
Yes, ma'am. So performance analysis, from performance analysis, we can give here, we compare proposed multi-input CNN with existing 3 algorithm, optimized CNN, convolutional autoencoder, and deep neural network. So the proposed method, the overall accuracy reached 85%, compared to 78% of optimized CNN, 75% of autoencoder, and 68% of deep neural network. Similarly, precision, recall, F1 score, all these were highest for proposed method. In conclusion, to conclude, the proposed multi-input CNN successfully improves crop classification performance by combining spectral information with vegetation indices. The model extracts more discriminative features. It achieves the highest accuracy, precision, recall, F1 score, and all these parameters. This result confirms that multi-input feature fusion is an effective strategy for hyperspectral image classification. And significance of this work, the research has practical application in precision agriculture. It enables remote crop classification, monitoring, crop health, and early detection of plant stress and disease. Such information can assist farmers and government agencies in improving agriculture productivity and resource management. In future scope, the proposed model can be extended by integrating multi-source satellite data such as microwave, hyperspectral, ultraspectral sensors. It can also be applied for crop yield estimation, crop area mapping, and classification of additional land cover objects. So future optimization may improve classification accuracy even more. These are the references. Next slide, please. These are the references used in the research, including recent works. So in hyperspectral image processing, deep learning, and crop classification. Thank you very much for your kind attention. I sincerely thank the conference organizer for providing this opportunity to present my work. I would be happy to answer any question or discuss the research further. Thank you, ma'am.
Thank you, Kavita, ma'am. What are the basic objectives of this article?
For crop prediction, so if we are using remote sensing data, so using remote sensing data, crop should be effectively predict by achieving maximum accuracy. This is my first objective of this research.
Are you addressing any feature selection mechanisms, ma'am?
Features are selected using CNN method. So automatic feature selection can be occurred using convolutional neural network, and features are selected from 2 inputs. First input, that whatever hyperspectral segment I have extracted, from that features are selected. And second input,
I got your point, ma'am, but my question is, since there are a few existing selection methods available, on top of them, are you proposing any new method or working with PCA and other existing mechanisms?
Existing mechanism. I use existing PCA method and CNN method. I am not proposing.
So feature selection is not your objective, correct?
No, sir.
Okay. Next, what is hyper selection mechanisms, madam? Are you addressing any such?
Hyperspectral. Okay. So in hyperspectral, if we are using that band, band.
Your voice is not clear, ma'am.
To band. Bands are there. So though I have selected only those bands which address greenery, or which can extract features from green vegetation indices. So in this way I have. His
Okay,
voice
madam.
is
Thank
not
you.
audible. Welcome, sir. Thank you, sir.
Thank you so much for such an insightful presentation.
Thank you, ma'am.
We'd like to now move forward. I would like to invite Kumati Reddy Akhila to present her paper on artificial intelligence applications in precision agriculture and predictive healthcare, a unified approach. You may start your presentation.
Yes, good afternoon, everyone. Is it audible, my voice?
Yes, you're audible.
Shall I share my PPTs now?
Yes, please.
Right. Good afternoon, everyone. This is Akila Komati Reddy. Right, today I'm going to present about research paper, Artificial Intelligent Applications in Precious Agriculture and Predictive Healthcare, a Unified Approach. Right. See, here I'm going to, my paper used to develop one unified AI framework for both essential sectors, agriculture and healthcare. So this is the abstract of my paper. Here we are integrating two sectors. One is the healthcare and the one is the agriculture. That means here, previous papers, they concentrated on individual applications for the agriculture and healthcare. When come to the agriculture also, they use so many applications to predict the, to take the decisions and all. But here we are integrating by using we are integrating all the applications here by using the unified AI framework. Right, and multi-source data integration. Here we are collecting the data from multi-sources like sensor data, imaging data, electronic health records. From all these sources, from these sources we are collecting the data and we are pre-processing the data, analyzing the data. From that we are taking the decision. The system, AI system, will take the decision and recommend to the farmer or doctors to the best productivity. Right, and come to the agriculture applications. Basically, my paper implemented about the agriculture field. The healthcare is the advanced extension of this paper. Right. See, come to the agriculture applications. Here, by using AI, we are using AI for crop yield prediction, soil health analysis, and to detect the disease of the crop, and resource optimization. That means we can save the resources when we have the limited resources. We can, based on the best recommendation support, we can save the resources to improve the agriculture productivity. Come to the healthcare applications. Here, the AI, we are using AI applications we are using in healthcare to early disease detection, and we can monitor the patient situation also, and we can predict analysis to enhance the healthcare outcomes. Right. See, by using this the proposed system enables real-time monitoring on automated decision support and improve the prediction accurately, and we can save the cost also. We can reduce the cost, we can reduce the time, and we can improve the sustainable in agriculture. Right. And come to the introduction. See, this AI system, whatever we are talking about, AI framework, unified AI framework, will enables the decision support and automation. And nowadays, agriculture, whatever these essential sectors, agriculture and healthcare, facing so many problems like changing climate and marketing, everything. So quality of the food. So all these are agriculture nowadays, agriculture facing the all these challenges. right? So by using unified framework, we are, here we are using one AI application, one AI system to monitor all these together, right? See, look at here, one diagram is there, AI in agriculture. Here we have field operation management. That means, minute to minute monitoring the soil, what is the soil moisturizing, how much resources we have. All these we can monitor by using the census data. By using sensor, by using sensors, we are collecting the data of soil, environment, climate changes, everything done here. And come to the livestock, this is completely about the marketing, how much we are pricing for the products and all, that will done here. This is completely about the marketing sector. And here crop management, here we are predicting predicting the crop yielding and early disease detections and weed control. Everything is done by the sensors, collected by the sensors. And next one is the weather forecasting. This is the one more one more input data, that is the sensor environment reports. And next one is the precision agriculture. That means the recommendation system will give the best suggestions to the farmers and doctors based on the prediction, right? So come to the AI in healthcare. Here we can detect early disease, and we can monitor the patient situation and all, and we can give the best suggestions, best medicines by using the accurate prediction. And here we are using some IoT devices like sensors, robotics. All these are helping to improve the productivity of the agriculture. And come to the research objective, especially in this paper implemented only about the agriculture. And it will support to the healthcare also. That is the extension of this paper. Right. See, this slide showing the applications of artificial intelligence in agriculture. See, this AI system will collect the data from all the, all the sources like sensor data, crop image, weather data, and about the resources. All these are the data collection of the sources, and collect the data, and it will pre-process the data. That means it will clean the data, normalize the data by using algorithms. Here we are using algorithms, ML and DL algorithms, for crop yield prediction using random forest regression, and crop disease detection. We are using CNN algorithm, and smart irrigation, random forest, and decision tree using sensor data. And come to the healthcare disease prediction, we are using AN algorithms, and medical image analysis will done by the CNN algorithm. And here in applications of artificial in agriculture prediction, agricultural robotics we are using, and sensors to collect the data and monitoring the minute to minute monitoring the soil, weather, and cropping and all. And here we are using classifications and
Sorry
forecasting,
to
also
interrupt,
marketing.
but I'd request you to conclude your presentation now.
Yes, ma'am. See, my proposed, my research paper proposing AI system. This will helps to the helps to the farmers by accurately predicting crop yield and optimizing irrigation. That means by using this, we can we can save the resources Say that means how much we need, that much we will use. That completely depends on the prediction. And this paper, it is also has the potential to support healthcare application in future. Yes, ma'am. This is the methodology of my paper. Right, ma'am. Any queries? Excuse me.
Hello, madam.
Hello.
Uh,
Sir, is it audible?
yes.
Yeah, good evening,
Thank you
sir.
very much for your presentation. Coming to your paper, have you not mentioned that which crop that you are taken into consideration while generating these results?
Sorry, I didn't get you. Which crop? Say,
Yes.
in anything, sir. It's
It should
completely
not.
suitable for the agriculture.
No, it should not be.
Actually,
If I am not wrong, because every crop has got its own characteristics and weather conditions. So it is going to take those parameters as a crucial thing while building the model.
actually, this paper is proposing about the unified AI framework, sir. That means only one framework we are using for agriculture and healthcare, because both the sectors will need some more large data, and it requires proper prediction.
True, but identically those two are two different domains, right?
Yeah, two
So
different
how can
domains,
we
but
able to bring them in
both
one roof?
yeah, sir, both data driven is same, sir. Both sectors need large data and same prediction system decision making.
I'm sorry to interrupt you. Maybe both the domains working with the same kind of algorithms called supervised or unsupervised or reinforcement. However, looking at the basic perception of input, those two are two identically different. You
Yeah,
may
sir.
apply the same algorithm,
Yeah,
but those two must be addressed independently, not as a common.
independently, sir. But that is the extension of my paper. Whatever healthcare is the extension of my paper.
True,
In
madam.
my paper,
Okay.
I'm presenting only about agriculture. In this also, in AI also, we are using so many applications, right? To test the soil, we are using some other applications, and to analyze the weather reports, we are using some different
Yes, I got your
applications,
point,
right?
madam. When it comes to
Okay.
even soil testing, so which of the soil is suitable for rice may not be suitable for wheat. So when
Yes,
you
sir.
are bringing them into a general consideration, probably the results or the outcomes, whatever we produce out of our framework, are going to not draw the actual conclusions that actually what you thought of.
Yeah, I got your point, sir. Actually, this is
But it should be very specific
first.
than general.
Yeah, sir.
Uh,
This is the first step, actually. This is the first presentation. So we
is it is
need
a
to
literature survey,
concentrate on
madam?
that. Yeah, it's there, sir.
No. Is your paper is a survey paper, or does it has any results?
I need to check out that, sir. Results is there. You are asking about literature, sir?
No, madam. What kind of paper it is? Whether it is a survey paper or it has got some results as well.
Survey paper, sir.
Okay, thank you, madam.
Yeah, thanks, sir. And thank you so much to give this opportunity, ma'am.
Thank you so much for such a wonderful presentation.
Thank you, ma'am.
Now I'd like to move forward and invite our next Prasanna to present his paper on enhancing raft consensus security using trusted execution and cryptographic anchoring. You may start your presentation.
A warm welcome to one and all present here. Am I audible?
Yes, Prasanna, you're audible.
Yeah, I'll start my presentation. Is my screen visible?
Yes, your screen is visible.
Yeah. Is my presentation is visible?
We can see your Zoom screen.
Okay, give me a second. Okay. Is it visible now?
Yes, your presentation is visible. You may start.
Yeah. Okay. Well, a warm welcome to one and all present here. Myself, Prasna here from Defense Institute of Advanced Technology, Pune. My paper is based on the consensus algorithm, which I have mainly focused on Raft. The title of my paper is Enhancing Raft Consensus Algorithm Using Trusted Execution and Cryptographic Anchoring. So the agenda for today's presentation will be the motivation for my research and research gap, objective, literature review, architecture of my model, algorithms I've used, and the experimental results and discussion and future works. First of all, Raft is a simple and widely used consensus algorithm in recent days, assuming false rather than malicious behavior. So we need a strong integration without partial BFT to communicate the cost. So the problem statement for my paper will be um, with the existing solutions, I need to uh, reduce the uh, reduce the lightweight of the raft and increase the security of the raft. So, according to the research gap, there is no lightweight raft based protocol, and the existing trusted executive works protest execution only. So, crypto raft, that is my given solution, integrates both of them. So objective of my work is protecting the consensus algorithm, detect log tampering, for which I will be using Merkle tree based on state digest, and prevent raft linear communication complexity. So according to the literature review, Raft is simple, as I mentioned before, it is simple and efficient and it is widely used. The problem with the partial BFT is Byzantine it is Byzantine fault tolerance, but it is too expensive, so not everyone is using. So coming to trusted executive is it is hardware based execution system. So according to the cryptographic anchoring, it is an external integrity verification. So the according to the literature review, my gap motivation is cryptoraft. So according to my paper, I have three layers which acts as my architecture. First layer will be raft consensus layer. Second layer is for secure execution, in which I will be using TEE, that is trusted executive environment. And third one will be cryptographic anchoring layer, where I will be using Merkle tree for log tampering purposes. So consensus algorithm basically consists of leader election, log replication, state machine replication, and enhanced with trusted execution. Here, the leader election is the important step. Sorry. Hello. Can I continue?
Yes?
Yeah. Okay. So election is the important step in the raft consensus algorithm, because once the leader is elected, the leader will be choosing whom should execute their functions in the network. So it is very important to secure that layer. So to protect this leader election, I am using secure execution layer, where I will be executing the leader election, that is leader selection process, entirely in trusted executive environment, which validates the entries and request host. So in the cryptographic anchoring, there I will be using Merkle root, which is used for finding who and all is accessing the network and how they are accessing. For example, if one node is coming and making changes, then it will be noted, so that if any malfunction or any attacker come into the network, I can easily detect them. So this is the workflow where the client will request, and according to the request, it will go into the secure execution for leader election. Then from there, if any activities have taken place, it will be replicated, and the majority commits, and it will go for Merkle digest, where it will mention all the entries and exits and all the function, and it will go to external leader, and it will go for verification. So according to the threat model, it comprises of leader compromise, RTC forgery, and log tampering. So the methodology will be Python prototype, T-inspired execution, Merkle tree hashing, and containerized distribution environment. So these are the results. From the results, we can see that my proposed crypto raft is more efficient than raft and partial BFT. By seeing the latency, it is better than raft, but little less than partial BFT. That is because I am using two verification, that is TEE and cryptographic anchoring. So that's why it is less, but according to the cost of PFD, but minus very less. So that's why I have proposed this. So security analysis will be detecting the log tampering and reject the forged RPCs and prevent malicious leader manipulation, because leader election is the basic and main criteria for a raft consensus algorithm. So if we see the comparisons, in TEE, in RAF there is no TEE, but in my proposed solution I have integrated TEE and cryptographic anchoring. So if we come for normally if we see the comparison, we will consider latency and throughput. So the basic criteria is latency should be high and throughput should be low. So if we see here, the latency is moderate for our case, and it is better than raft and PFT. So like my limitation and future work will be, I will be integrating the hardware part, that is Intel SGX or AMD SVG slash SNP, and adaptive anchoring frequency and large scale deployment. So my conclusion will be cryptograph is a combination of trusted executive environment with cryptographic anchoring, which improves the security of the raft without increasing the cost of consensus algorithm, and also providing the simplicity of the raft. So it will be an alternate for heavyweight BFT, because minus less weight. So that's all from my part. I'm now open to questions. Anyone have any questions, you can ask me.
Sir, do you have any questions for him? Srinivasulu, sir, do you have any questions for him? It seems that is not the case, so we'll be moving forward.
Okay. Thank you everyone for listening to my presentation, and thank you, ma'am. Thank you for giving me this opportunity.
Thank you so much, Prasanna.
Thank you.
I'd like to invite Swaraj Zagdare to present his paper on improved medicinal plant classification using ensemble of CNN and transformer models. You may start with your presentation.
Yes, good afternoon, ma'am. Am I audible?
Yes, you're audible.
Yes. Is my screen visible?
Yes, your screen is visible.
Yeah, so good afternoon, everyone. My name is Faraj Agdare, and today I am presenting our research work title, like improved medicinal plants classification using ensemble or CNN and transformer models under the guidance of Dr. Hemangi Pandey from MIT World Peace University. So medicinal plants are identified very important in healthcare because many medicinal plants have similar visual characteristics. So making manual identification is difficult. So our work proposes an ensemble deep learning approach to improve classification accuracy. So here the study proposes an ensemble based medicinal plants classification using leaf images and deep learning. So the question arises that why we are using the ensemble learning model. So instead of depending on only one model, we combine multiple deep learning models. So it becomes very like accuracy will be increased and individual model first we gone to the individual model also to get the accuracy. But why this ensemble it is used because each model learns different visual characteristics. For example, like efficient net captures efficient image features or dense net captures features effectively. So we gone to the ensemble learning part. So here we gone through aggregating the prediction of different models together to accurate and stable results to compare a single model accuracy. So these are some my literature review papers I gone through to get my research paper done. So this I will give an overview. These papers like most significant on medicinal plants identification. So in this some studies focus on like disease detection while others use like explainable AI or mobile development. But however, only most exciting research papers uses this CNN with transform models to apply ensemble learning. So we decided to go through the ensemble learning to part means to ensemble all these CNN models together and to work with. So after reading this research paper, these were my research gap. From the literature survey, we identify several research gaps like most exciting medicinal plants focuses on a single deep learning architecture, limiting their ability to capture diverse visual characteristics of plant leaves. Very limited work comprises CNN and transformer models. Like few studies investigate ensemble learning to improve classification performance. And additionally, class level analysis and confidence based predictions are often missing. So these limitations motivated our research motivation research. This is our motivation. So our motivation is to develop an intelligent system that can accurately identify medicinal plants. So like medicinal plants play a crucial role in traditional healthcare system, pharmaceutical research, and biodiversity convergence. So incorrect plants identification may lead to improper medicinal use. Therefore, we wanted to build an automated, reliable, and scalable deep learning solution so that it can help our plant identification using real-world applications. So our objective was to develop an automated medicinal plants classification system and to compare CNN and transformer architectures as well, and to design an ensemble model, improve classification accuracy. So these were our objectives in this. So this is our proposed workflow, like to collect the data set, to make the pre-processing, use the CNN models individually, and last to get the accuracy. So overall, this first I gone through this data set, like total were 2100 images. These were some pre-processing technique like image resizing, normalization, data augmentation, conversion to tensor, trace split, and data load setup. So this gone through like it helped me to reduce my image to 2 to 4 by 2 to 4 pixels and to data augmentation because limited data set and to increase the data diversity to reboost lighting and orientation changes. So these were my data pre-processing techniques. So in this, I implemented these 5 models that were mainly efficient net B3, then ResNet 50, VIT based transformer, RSNet 101 and DenseNet 201. So transfer learning was used to reduce training time while improving performance. These were the layers used to fill it like efficient net were having 350 plus layers, DenseNet were having 50 layers. So it used to refine it. We use efficient net B3 because it is the average B3 layer. It consists of B0 to B7, but to like this the kind of data set, it will be used like more efficiently. So we gone through B3, efficient net B3. So this were my performance metrics, like overall accuracy of these individual models we gone through. Like it was efficient net was 98%, RSNet 50 was 98.05%, VIT base was 98.41%, and ResNet was 197, and DenseNet was 98.05. So we gone through, like I mentioned, like we gone through each ensemble learning, which we conducted ResNet 50 plus 101, that where accuracy was 98%. Then along with this were the matrices, we got the results we got. But why we got only efficient net B3 plus DenseNet 201 plus ResNet 101 was because this model gave best accuracy because that's where deep sketch depth, width, and resolution effectively. DenseNet 201 deep network with strong features reuse, and ResNet 101 residual connections and strong generalizations. So what exactly did we do in our ensemble was we loaded three trained models, that is EfficientNet B3, DenseNet 201, ResNet 101, and passed the same image through all these models and calculated the softmax possibilities, and we record the final predictions from it. So ensemble is important because of the higher accuracy, like it reduces overfitting, more stable predictions we got through it, and it is used in industrial and competitions, like ensemble models are widely used in medicinal imaging, Kaggle Winco solution, because they deliver strong, stable, high confidence results. So along with these were my conclusions from this, like develop an automated medicinal plants classification framework using deep learning, apply transfer learning, advanced augmentation techniques, evaluated multimodal deep learning architecture, ensemble class configurations, and ensemble improved classification performance over individual models. So we develop an ensemble deep learning framework for medicine class classification. Our works demonstrate that ensemble learning is an effective solution for accurate medicinal plants identification. So this is future work we can do, like we can include bark, flowers, fruits, and stem in the data set. We can increase data set, develop a mobile application for it, and integrate additional explainable AI. So these were my references, and thank you. I'm ready to take any questions, everyone.
Hi, Swaraj. Thank you.
Yes, sir. Thank you.
How the medical plant classification is different from the other tree classifications?
Because as means medicinal plants are individual like that, like Tulsi will have it's such a data set diversity, so it can be different.
No, no. My question is how a medical plant is
Yes.
different from any other normal plant.
Because like it will have medicinal use.
Purpose is different. When we were referring to the data set,
Yes.
when you are scanning a leaf of a medical plant versus a normal plant leaf, hardly what makes you to differentiate of those two leaves?
Because like medicinal plants contain like bioactive components, like their data set will be different. Every medicinal plant is different. Not every plant is a medicinal plant. Like Tulsi, for example, we taken Tulsi, Neem, aloe vera. So the data set was different from regular plants. That's it.
Okay. So there are n number of medicinal plants, of which how many types that you have taken into consideration?
So we taken only 57 medicinal plants as of now, like 3,000 images. So to check
How many
the
parameters?
parameters based on like real world examples only, like we gone through the optimizer
No,
Adam and
no,
learning
no,
rate.
no. In your presentation, somewhere you mentioned you've taken into consideration of only 2,800 each.
Yes, yes.
So where each plant has captured of its properties in how many parameters?
like only we gone through leaf, that's it. Means instead automatically run visual features for leaf imaging training,
No,
like
in your
leaf
data
shape,
set
leaf size.
description, certainly you might have mentioned that. 2800 are the rows. What about
Yeah.
columns?
No, sir, I will get back to it.
Okay. So can you name few techniques that what you have applied for classification?
We take an individual model accuracy, means CNN model to train the dataset only.
So what about accuracy?
Like accuracy, we got through tra training the models, like using this CNN models only. We got the accuracy, like these layers we gone through, and we fine-tuned the layers, and the accuracy was individual. First, we got about 98% for the efficient net, RSNet 5098. Then overall, we done the ensemble through this to these models, and we got the overall accuracy.
Okay, Swaraj, thank you.
Yeah, thank you.
Thank you so much, Saraj, for your insightful presentation. Now I'd like to move forward, and I'm so sorry if I mispronounce your name. Sareen Mbake Jean, I'd invite you to present your paper on LSCPM Lightweight Security Protocol for self-reconfiguration by clustering on programmable matter-based modular robots. You may start your presentation.
Hello,
Yes, sir.
can you see my screen?
Yes, I can see your screen.
That's okay. Hello, everyone. My name is Ring Makejan. I'm a PhD student at Asanseke University in Senegal. It's a great pleasure to participate in this conference and present my article. WUSM is a light security protocol for security configuration by clustering on program matter based modular robot. We will first give the online. Firstly, we give the introduction, assume the context and the application. After we give the background, propose its solution, estimate and result, and finish a good a conclusion and a perspective. Firstly, a program matter. After traditional network, sensor and RFID network has have ability to out into the Internet of Things, and a matter that can change its physical property, just as changing shape on demand can automatically iterate on the physical property. And a program matter is a vast fleet of just the front between the robotic and the computer science, and ease of the micro robot can place in a regulated can communication with the neighbor to neighbor. And a modular robot made of a burst initial pre-configuration model can move in to change the shape of the cell. A bot can communicate to the shell of the configuration. After this, the program matter, if you see the image in the video, you see it's possible to have a gap to end the control of a computer. In the modular robot, I have a many modular robot. If you see this model depend of the object of the model you create. In a modular robot, the modular can execute the same program, has an ID, can move it using a message for the communication and communicate the wish to the neighbor and the neighbor. This technology is applied in several areas, such as in a construction, in the environment, and in the nuclear, the space exploration, and the strategy and the local mission. After this, we view the context and the application. A modular robot system are difficult to classify to be divided to vast the different shape. Some models are controlled by a computer, another directed by a leader, a model during the self-configuration. And if you contextualize the security of protocol, it's depend on the architecture. This framework on application depend on the program matter. There are some characteristics, mobility, number of neighbor, degree of freedom, and the scope. We will base it on work on a lips and scope approach. We will focus how web programming matter in the robot and a building block and 2DC atom. A security context in program matter, it same have a similarity without the wireless sensor network and the internet of thing. And the difference is the wireless network in the internet of thing. A very large number of a model are in protect and a particle are anonymous and a particle no centralized control. As a security algorithm proposed for wireless network and internet of thing would be suitable to sensor on neighbor. After this, there are some protocol we use it to the security in the program matter. There are provision for version different level security, AKPCM using a as function, security service authentication of module, key management and confidentiality, escape allow to secure to self-reconfiguration process based on clustering. After this, we compile it for the protocol, space complexity, the time complexity, and the transmit complexity, authentication, and a confidence. After this, we propose a solution. We propose LSM, a protocol security self-reconfiguration by clustering on program matter, basic modular robot. A live security protocol for clustering basic self-reconfiguration, based on the LIPS and escape protocol approach with initial key, offer two types, a key pair between a header during inter-clustering communication and a cluster or group key during the inter-cluster communication using an ASP function, symmetric encryption, decryption, XOR operation, driving function, and NOS. After this, we compare it to validate how proposition using Avispa tool for certified and the visible simulator. The system assumption to study a system including to blink blocker, the asset is distributed and controlled by a computer or a leader model. A model only communicate without an immediate neighbor trust on the connector. A security challenge, the model are limited in resources without, it's not possible to use the traditional security mechanism. There is not central element that manages the authentication. After this, in the solution, you have two phase, initial phase and initial key, and the distributed security phase of the skeleton formation, inter-cluster communication, intra-cluster communication. After this, in the inter-cluster communication, in the first step, the C-edge model generate a loss with in random variable to agree. Afterward, we will shop a nose so that we send a clean. After this, we compute n in one. We compute x k init. After this, we draft the symmetry k. Sell a symmetry k and x. The model CHI. CHI receives the message. You draft to n0 in 0. We have the in 0. If you have the node, you draft the guy initial. After this, we decrypt the message. If you verify if the N1 adds the hashing node, if this correct, that's why the add the two heads header sharing a key different to security a communication feature. After the intercluster communication, we have the intercluster communication. In this, we have a communication security of the head cluster and the member of cluster. In sharing the same key, sharing the key sharing between the C at the MC and the MC at the security protocol in the intercluster. After this, we compared how protocol in the transmission and authentication and number of key. After this, we do a simulation on a mathematically compare how solution and another the correlation and escape, and we see they have very different how solution and the another. After this, we use Avispa to test it, their found attack or no attack in the solution. If you see the message, the goal is satisfied, is safe. There are not attack in your solution. The image is the right attack found. In the intruder, no, the star in it, there have an attack in this part. The invisible sim allow you to see events. Excentric of message will have received or not. And the image of the left show the initial phase where the white model in the initial model that must authenticate to another model. This is province the image of the right was the receipt of the message tune of the initial key in blue, and the model is red plus solve the authentication in the set enter communication. The simulation invisible sim allow it to know the simulation time according to the number of the model firing to the
I'm so sorry to interrupt, sir, but I'd request you to conclude your presentation now.
Okay, that's right. After this, we see the number of the messages during the simulation of visible sim. At the end, we do the conclusion. We propose the LSF a new security protocol for the self-reconfiguration of programmable matter and secure the intercommunication of the model. The proposed protocol implement into mutual authentication mechanism, driving a key from an initial key, and LSM using the cryptography mechanism to implement a key derivation security protocol in a robot system. After this, we do Avispa and visible sim to simulation in more economy in the term of execution time, cost, but also the number of the message. The protocol ensures several type attack, notably play and fabrication attack, without as the most frequent and difficult to come. In the future, we will try to measure the energy of consumer during the simulation for its model, verify the factor in terms to calculate creative operation. After this, we will also improve the protocol without electricity and describe the ASCII number is by quality, efficiency, and robust protocol. Thank you. If you have any question, I am.
Thank you so much. I'd like to ask our session chair, sir, do you have any questions for him?
It's fine. Go ahead.
Okay. Now we'll be moving forward.
Thank you.
I'd like to invite Meeta Mehta to present her paper on SWOT analysis of blockchain technology in Indian healthcare, a critical review. You may start your presentation.
Yeah, just am I audible?
Yes, ma'am, you're audible.
Okay, my slides are visible. So this is yeah, good afternoon, everyone. This is Dr. Nita, and this work is of mine. Dr. When worked on this, and we also joined the company and presenting on her behalf. So I present a critical review on the potential of the blockchain technology, which is transforming the Indian healthcare. I just need to mind it here for the session chair present participants that this is major we have worked on. She is MBHHM student. majorly worked on the applications, not the architectures. Okay, and the outcome of this is a SWOT framework, and study also evaluates both the opportunities and practical challenges which are associated with adoption in the Indian evolving digital healthcare ecosystem. So, as before I proceed, I just want to know, have a self introspection. How many of us have had repeated the same medical test before because of the record were not available, right? So this is exactly the blockchain technology solution and the thought of working on such research as a part of this. So these are the objectives of our research to critically review. This is not a systematic review, it's kind of a narrative. We went to the typical way to the literature of blockchain technology. Yeah. The time span of this work was relatively for 3 to 4 months. She had worked on it extensively to evaluate its strength, weakness, opportunities, and the threats in the Indian healthcare context. That was the second objective. And we also aim to identify the implementation challenges and recommend strategic directions for the policymakers and healthcare stakeholders. So while I mentioned that there is the key question which is can blockchain solve the systematic healthcare challenges like fragmented healthcare data or limited interoperability, data privacy concerns? There have been certain medical frauds. We are aware that of in the western or the southern region or maybe certain parts in the study groups. There have been sustainable amount of the duplicate investigations which have been also been recorded and which is rising and another the digital adoption. Still, Indian healthcare system is not yet prepared for the digital adoption. So there are some cybersecurity threats also prevailing around it. And we know India is around the world's largest healthcare system, which is serving more than 1.4 billion people. But despite remarkable progress, the healthcare information remains fragmented. That is what we intend to work on. Our study has a critical review and existing literature, and we aim to answer these research questions while identifying the recommendations for successful implementation in India. What are the strengths and so on? This is self-explanatory. I won't be reading it again and again. Blockchain in healthcare. So majorly we found that blockchain has become more powerful when it is integrated with the IoT devices. Wearable can continuously monitor patients and secure transmit data into blockchain-based healthcare record, which supports the chronic disease management to improve the access to the healthcare facilities. Since I mentioned that it does not it would eliminate the chances of duplicate record, which we mentioned in the earlier slide. And it also works on the authorized healthcare providers. It would have the easy patient record the controls access. This has been discussed in these studies, which has been placed here. Of course, when we discuss the blockchain, then since 5 years, we have been discussing. Our study has majorly worked on the last 10 years data. And we found that the major features for this is secure, decentralized, it is immutable because of its architecture and patient-centric. So the SWOT framework, majorly we would like to mention that blockchain plus EHR and IoT, which I had mentioned in this previous slide, along here also, I would like to say that benefits also includes the remote monitoring, smart hospitals. Nowadays, most of the hospitals, tertiary hospitals, which are working, our Symbiosis also has one of the tertiary hospitals. And we only struggle, to work, like give away those functions which can be done by technology rather than mainly, clinical staff is constantly, banging their head towards this. So smart hospitals, and it has a lot of smart records, better clinical results, and of course, there will be a reduced paper load. So our studies, this framework majorly highlights that based on our critical analysis, we came up with this SWOT analysis, and we highlighted the relevant literature. This framework highlights that blockchain offers a substantial benefits, but in terms of decentralization, patient empowerment, tamper-proof record, which is a main blockchain benefit, which has been discussed in a lot of literature. Especially when we talk about in terms of India, the Ayushman Bharat Digital Mission create a stronger foundation for the blockchain adoption. There are a lot of recommendations which have been going on around. Digital India initiative which government is pushing a great. Yeah, so earlier no other paper would have done this effort and collectively presenting with the SWOT effort, and majorly when we talk about the challenges, yes, the scalability issues to cyber security risk, because it is still, we can say that blockchain is a safe in terms of immutable, which had already presented from the literature. It has still lot of scope in terms of the integrity, clinical trial, patient record, and data control. However, but the skill shortage would remain a kind of major challenge for the India, the country like India. So our review identifies our major implementation barriers without standardized health data format, robust cybersecurity or workforce skill, which I already mentioned, and the ethical issues. So, we try to, rather than we try to the policy recommendations which we are recommending in terms of the strategic roadmap. It says that how the nation standard, so there has to be some clear-cut guideline when in terms of the government, whenever, even if it's Ayushman Bharat Yojana implementation, we recommend that HL7 FHIR, which are the fastest healthcare interoperability resource guideline or standards, or consortium blockchain related pathways to healthcare workforce training is a major kind of a suggestion which is based on our policy, our literature review study-based recommendations. Of course, many papers are also talking about the capacity building or nation-wise adoption, but still we say that the pilot projects will help. So this path roadmap is the outcome of our study. We also mentioned that there are a lot of practical, kind of implications we are suggesting through our, paper. It says patient. So secure the ownership of the health record. The complete health record is something the no compromise. When the blockchain backend data entry takes place, hospitals, they have to have better interoperability. Governments, they need to have a transparent healthcare system. For researchers, there are a lot of practical implications we have suggested in the paper, and another paper she is working on that, where she would be taking some of the responses in the future research as a part of the suggestion she has already started working on, and supply chain integrity. So it is not, blockchain is not going to enable only trust, transparency, or security, but it will transform the digital healthcare, especially for the country like India. So yeah, this reviewed literature, blockchain, constantly we try to collect the data. We actually researched around 50 papers, and these are mostly the application based rather than architecture, which I have already mentioned. So we majorly worked on EHR or health information exchange, pharmaceutical supply chain, IoT wearable, clinical research, smart contracts. But some of the application papers we have not, which are not intensively been talked about in the earlier research of international guideline, like insurance claim or organ transplant or genomics, medical telemedicines. These things we could have further covered. These are our suggestions for the future research based on a critical review. Of course, the empirical study of researcher response she has already started working on, but yeah, these are the pathways for the future researchers. These are my references.
So, do you have any questions for her?
Hello, madam.
Yeah.
Am I audible?
You are audible.
Okay. Thank you, Mehta ma'am, for your presentation. Can you briefly summarize the basic objectives of your article? Hello.
Ma'am, if you're speaking, you're still muted.
Sorry. I'm
Yeah.
so sorry. I was speaking. And we majorly intend to critically review the literature which is based on the blockchain technology, sir. The papers which were from 2015 to 2025, the student had studied, which had EHR, some health information exchange, pharmaceutical supply chain, or IoT or wearable. So these papers, we did a critical literature review and we found what are the strengths in the blockchain which has been academically been captured in the literature, in the study spectrum, academic spectrum, and majorly we covered articles, journal articles which are of high quality.
Okay.
We omitted the conference papers and editorial and all.
So it is a comparative study?
It is not a comparative study. It is about the Indian healthcare system blockchain application potential, where we analyzed it from the SWOT analysis perspective. So we synthesized the literature into SWOT analysis.
That's what. In your
pathway.
article, you are mainly focusing on SWOT analysis of the existing things, correct?
Existing thing, and we have also recommended strategic directions for the policymakers and healthcare stakeholders.
So are you proposing any methods or algorithms, framework as part of EHR?
No, that is not the scope of the study, but we have given the guidelines of the pathway. That's what I'm saying, based on our study.
Does it based on any scientific evidences or a mutual understanding?
No, not mutual understanding. This is based on the literature. We have also gone through the future research agenda of those, and we have also read the WHO reports, as well as we have also read the Estonia, one of those, and USA healthcare study also, what the international healthcare blockchain adoption is there. Based on that, we have given the strategic path.
All right, ma'am. Thank you.
Yeah, thank you.
Thank you so much, ma'am, for your wonderful presentation. Now we'll be moving forward. And I'd like to call upon, and I'm so sorry if I mispronounce your name, I'd like to call Khotso Majato to present his paper on toward production-ready reinforcement learning scheduling in digital twins, a transfer learning and failure analysis approach. You may start with your presentation.
Thank you so much. Am I audible that side?
Yes, you're audible.
So let me share the screen. Just to confirm, is my screen also visible?
Yes, your screen is visible.
Thank you. Welcome everyone. My name is Khotso Majato. I'm a master's student here at the Central University of Technology in the Free State, South Africa. Alongside with me is my co-authors, Dr. Kutsia and Prof. Kuriakos. And then today I will be presenting paper number 715, which is our work on making reinforcement learning agents production ready inside a Simulink-based digital twins. We'd be also using a transfer learning and failure analysis approach throughout this content. So just to move forward, I would just like to show an overview of what I'll be discussing today, which is the motivation and problem, the digital twin environment, the root cause analysis, the transfer architecture, the results and validation, and then lastly will be the conclusion. I'll try and move quickly through each section, but I'll mostly focus on the section 3 and 4, which is the failure analysis and the transfer architecture, as those are the core technical contributions to this entire paper. So the motivation and problem statement, reinforcement learning with digital twins is well established, ideally in theory, but the practical integration into Simulink and multi-agent environments is poorly documented. So in our case, while I was doing the agent testing, the agent performed a 97.8% accuracy in a simple ramp tracking test completely, and then it failed when it moved to the full manufacturing plant. So it was stuck selecting same order every single timestamp. So if you see here on the specific case, it never transitioned to order number 2, 3, and 4. I'll explain further what is meant by orders, these orders that are mentioned here. So in all, this paper is a full account of why that happened and how we fixed it. So just to ground the view, we use a real water bottling plant model in MATLAB and Simulink. It has three sections, main sections, which is the source tank. Sorry, which is the source tank here shown at number A. And then we also have the bottling manufacturing unit, which is here at B. And then lastly, the filling and packaging unit, which is here at C. So the digital twin then helps simulate these orders, which can be from order number A, B, C, D, which is 4 orders. Let's say, for example, 4 customers. And then the simulation of the orders, it also manages the flow, the test files, and then it measures the responsiveness of the requested orders. So the plant model also has 4 subsystems, just to show you how it would look like in the MATLAB Simulink platform. Here we'd have the plant, the tank with the plant with the pump, and then obviously we'd also have the RL pump agent. Then we also have the RL decision agent, including the plant as is. Then lastly, we have another model that just checks if everything is completed once the orders have ran successfully, which is the episode is done. So upon these, we will mostly we'll focus only on the RL decision agent subsystem, which is specifically the order selector agent that is responsible for selecting the different types of orders, the types of customers that have sent through the orders, which, for example, it would be 4 customers in this case. And then the types of bottles that are actually used in this plant would be your 330 mils and then your 500 ml bottles with an 8-element fill state test vector. So the order selector must choose which of the 4 customer orders to process at each timestamp based on the delivery and the deadlines. Like I've mentioned, we'll mostly focus on the RL decision agent. So upon the study throughout the test and accomplishing the model, the RL model, there are 3 completely independent root causes that were identified through the systematic diagnosis. So if you check here, you'll see the first one, the first root cause was the uninformative observation space. So in this case, the observation space gave the agent no useful signals. So the raw POSIX timestamps look almost identical to the network, which was the first issue. And then the root cause number 2, if you check it, says that the unit delay on the reward signal was a bit faulty. In this case, the unit delay block in the reward subsystem broke the timing of the credit assignment. So the agent received rewards 1 step too late. And then root cause number 3 was the inadequate network and hyperparameters. So the network architecture was too shallow for the multi-step sequencing tasks, and the hyperparameters encouraged premature exploration. So each of these alone would cause failure. Together, they made learning impossible. So how did we fix this? We replaced the raw timestamp with a normalized agent vector. Then we also removed the unit delay block, which was causing an issue, which had the direct reward path, which restored the temporal credit assignment. And then fix number 3, we just added some network layers and then also worked to play around with the decay and the learning rate. Moving forth, the transfer architecture uses a 3-layer network, which had the 120, 120, and 64 layers. The key innovation is the observation design, which instead of the raw timestamp, we compute normalized urgency vector that directly encodes the scheduling problem. So a 0.1 flow ensures that the agent never ignores the less urgent orders. So when an order is completed, its urgency drops to 0, which signals that the agent to switch to another order. So the reward function uses a priority weighted based rewards with a strong penalty for the premature switching and for staying on a complete order. Here's a table that would classify or just give us a raw output of what the episodes we use, what they provide us, and so forth. So we ran the training for around 500 episodes, and then out of those 500 episodes, we ran it for 2,000 steps, each resulting to 1 million timestamps in total on a single CUP unit, single CPU core. Then the reward started negatively, but then stabilized around 150,000 by episode number 20, and then it held there for the remaining 420 episodes. Critically, the greedy policy evaluation static of a 175,000 exceeds the training average. So in this term, confirming that the learned policy generalized beyond the mixed exploration used during the training. Then the validation table then shows that the agent correctly selects order 1 from step 1 through 1022 here. Then switches exactly once the order 2 to order 2 when order 1's urgency drops to 0. Precisely the behavior that we designed for. And in conclusion, I'd like to summarize that the key contributions for this paper or the test that we done. The first one was the documentation of the transferred learning pipeline from DQN to multi-agent simulate digital twin. Second one, which was a systematic root cause analysis, identifying the 3 independent failure modes. And then also we improved the agent archives average, rewarding it with a 150,000 and correct priority-based order sequencing. Fourthly, we completed the Simulink integration guide, which is a practitioner reference for the RL into the DT deployment. And then lastly, we validated the standalone RL component for the border ensemble AI DSS framework. So fixing one, the most impactful practical lesson is that the 3 design elements must be transferred together, which was the observation space, the reward structure, and the network architecture. So fixing anyone alone is insufficient. Future work will be extended, me extending the episode length. So this would then fully train orders number 3 and 4. And then I will integrate the validated RL agent into an ensemble framework now, such as adding your other models like your GA and your PSO and so forth. And then these were the references that I used on my paper. That would be it for my presentation. Thank you for the time. If there are any questions, you are more than welcome to ask.
Thank you very much. I just wanted to know only why reinforcement learning, why can't other methods?
We chose reinforcement learning for the test bit for now, hence why we want to explore other ensemblement of the methods. Let's say, for example, we were going to then go through with GA and PSO just to see if at the end on the ensemblement part, how we can gather information, let's say, to make sure that the system performs better. So the objective here is to reduce system downtime in smart manufacturing environments using an ensemble of AI models. So it's not like specifically wanted to go through with RL. It's just the beginning or the start of different types of models we could use.
Okay. So other than reinforcement, did you thought of any other popular mechanisms?
Yes, like I've mentioned, we are thinking of GA, genetic algorithm, and then also the PSO, just to check if the ensemblement of those methods or models can assist in this study.
Okay. So what is the final accuracy that you have got?
Final accuracy still stands at 97.8, which is what I'm working on for now, so that at least I can go through on the other models and test from there onwards, just to see how much I would get afterwards.
Okay. Have you studied any accuracy influencing parameters as part of your model?
Not yet, to be honest, but it could be a good impact or addition to the SIS study.
Okay. Okay. Thank you very much.
No, thank you, Doc.
Thank you so much for your presentation. Now we'll be moving forward. I'd like to invite Ruxana Khatun to present her paper on VR-based puzzle game for learning Sanskrit and Arabic. You may start with your presentation.
Thank you, ma'am. Is it visible, ma'am?
Yes, your screen is visible.
Good afternoon, everyone. I'm Ruxana Khatun from Department of Design and Innovation, Jamia Millia Islamia, New Delhi. Today, I'm presenting our research titled VR-based puzzle game for learning Sanskrit and Arabic. This work explores how virtual reality can make language learning more immersive, interactive, and engaging through puzzle-based gameplay. Now, I'll briefly cover the motivation behind this topic, the methodology, game design, and implementation, usability testing, result, and finally the conclusion, along with future scope. So, traditional language learning often depends on memorization, which may which make learners find it less engaging. But virtual reality provides an immersive environment where users actively participate instead of only reading or listening. So we thought of designing a VR-based puzzle game that teaches Sanskrit and Arabic by allowing learners to reconstruct verses through a jigsaw puzzle design. Before designing our system, we studied various existing VR games and also the language learning applications that give us the study shows that VR improves interaction, cognitive engagement, learning, and problem solving. These findings were integrated in our research. So we adopted a methodology mixed method research approach consisting of qualitative and quantitative. The participants participated were between the age 18 to 35. They were evaluated and 30 in number. They were asked to complete the VR puzzle task and then provide responses through a usability questionnaires. Then the assessment is done on a technology acceptance model, TAM, and NASA task load index. In the concept, a Munsell color system is used in the game that provides a visual guidance to the beginners. And the end-to-end process is as soon as the user enters the VR, he finds the random pieces of the puzzles and interacts with the puzzles, completes the puzzles, then the reward is shown to them as the meaning of the words. Now, the game design and implementation. So the VR puzzle game was designed in Unity. The user interacts with the puzzle pieces and controls it with the VR controller and assemble the broken Sanskrit and Arabic pieces to assemble the verse. And the Munsell color system is used as a visual guidance. Then a timer is also added for the further challenge. This objective is not only learning the language, but also promoting cultural understanding through parallel learning of Sanskrit and Arabic. These are the screenshots that shows the VR puzzle environment. Here, in figure 3, the broken puzzle pieces are there. As soon as they are assembled, the next window unveils the puzzle completed and shows its meaning. So the usability testing is done with 30 participants. The method used was mixed, quantitative and qualitative. In quantitative, 19 Likert scale questions range between 1 to 5 were asked, and one open feedback last question number 20 is given that give the qualitative research. Then these were evaluated on a TAM bar chart. This shows the ease of use, usefulness, behavioral intention, and easy to use, usefulness, and engaging. The users found it strong. There was strong user acceptance. So the NASA TLX bar chart shows that the mental effort and the load on the cognitive load was low, performance was high, and the frustration was very low. So this shows that there is very low cognitive load on the user. So they find it a smooth experience, easy to learn. So it made the objectives like we designed a VR puzzle game system for language learning in an immersive media. It increased the excitement in learning the languages like Sanskrit and Arabic through game-based interaction. And also a color system is introduced in this, and access the efficiency of immersive system VR to augmented language learning. So the conclusion is the importance of this work lies in contributing to immersive learning, a puzzle-based game and visual guidance with the use of the virtual reality. This study shows that VR is useful in user engagement, user experience, and immersive learning. So there may be limitations to this, that this is only done in 2 languages. Further, future scope is that it can be given in more languages also. These are the references. Thank you.
Thank you, Rukhana. Do you thought of who are the target audience for your application?
The general peoples are there from different fields. I have researched with them. I've made them to participate.
Yes, sir. I'm sorry to interrupt, sir. I'm a co-author of this paper.
Yes.
So yeah, we have languages like in Jamia, the compulsory languages like Hindi, Urdu, and Sanskrit. So we are trying to gamify the entire learning experience for children, and this was just a very initial preliminary testing phase of that. So they have a compulsory qualifying paper in Urdu, and children who are from common schools and not from madrasas, they find it very difficult to learn Urdu. So we were trying to gamify on Figma also, on mobile also, computer desktop also, and a little bit of VR also. So this was the VR experimentation part of that.
Okay, got it, madam. Excellent. My only concern is, does it is school children or a university studying children?
The bachelor's first year students, master's first year students.
Okay, okay.
Yes.
So, in that regard, you are going to develop a VR enabled application where
Yes,
by
sir.
using that they can able to learn.
Yeah.
It is a kind of an interactive learning.
Yes, a gamification of normal language learning module. Yeah, yes.
Okay, okay.
Thank
Do
you.
you have any demonstration, madam?
We have it on Unity, sir, but it will be difficult to load. So you saw the
Okay,
puzzle.
okay.
So that puzzle has been entirely designed on VR, and it's a 2D puzzle. It's not a 3D puzzle. And they get a timer with that, and it's a game. And once they complete, the reward is that they get to know the meanings of the sentences they are trying to form. That is how the game is.
Okay, madam. Appreciate it. Thank you.
Thank you so much, sir.
Thanks.
Thank you so much for such a wonderful and interactive presentation. Now I'd like to invite Rukhsana again to present her next paper on web-based traditional toys and games of India.
Is it visible, ma'am?
Yes, your screen is visible.
So the my second presentation is titled Web-Based Traditional Toys and Games of India. This work focuses on preserving India's rich toy and game heritage through a user-friendly digital repository designed using the UX principles. This presentation will briefly discuss the motivation, methodology, brainstorming, card sorting, website design elements, Figma prototype, and usability testing. along with conclusion and future scope. India has a rich heritage of traditional toys and games, but the information is scattered across books, government reports, websites, and research papers. There is currently no single structured platform where users can easily explore this information. So our objective is to design a web-based repository that organizes the traditional toys and games into a meaningful categories, and while providing the intuitive and user-friendly experience. So for the study, we studied the different existing websites, including government portals, educational websites, and cultural repositories. Although these resources provide valuable information, they are text heavy, lack of structured categorization, and navigation is outdated. So these are designed for purposes other than toy documentation. The limitation motivated us to design dedicated repository focused specifically on Indian traditional toys and games. Our methodology is content curation from authentic sources such as government publication, books, and research articles. We collected information that organized through a brainstorming session and then validated using card sorting method with 5 domain experts having more than 15 years of experience. They helped us to create the intuitive information architecture for the website. This figure illustrates the UX followed during the design process, and the UI process followed during the designing. This is the brainstorming process, helped identify major themes and relationship among different types of toys and games. It formed the foundation for developing meaningful categories during the design process. We use card sorting with 5 experts to validate the organization of information. This method helped determine how users naturally group related contents. Then categories and subcategories were formed in this. The website design elements were used. These were based on user-centered design principles. We focused on intuitive navigation, responsive layout, and visual hierarchy, accessibility, and readability. A high fidelity prototype was developed in Figma for this, and 30 participants participated for this usability testing. So this is the final website prototype that I designed on that we designed on Figma. It have various categories, home and categories, major categories. Then under that, subcategories of that. Then usability testing is done on 2 frameworks: 5 ESOPs usability and SUS scale average values, in which there were questions given to the users for the evaluation process. Then results were 30 participants participated and evaluated the Figma prototype. They were asked to fill that questionnaire form. And after that evaluation, we found that SUS score was 75 out of 100, which is considered to be good on SUS scale. So to summarize, this work documents India's traditional toys and games in a structured digital format. It highlights their historical evolution, regional diversity, and educational value, while providing researchers, students, and the public with an accessible knowledge repository. So the importance of this work lies in preserving the India's rich cultural heritage of toys and games. And the limitation is that it's a preliminary demo work. Accessibility engagement has to be more meticulously thought of. The work is in English and vernacular dialects. The vernacular dialects can be integrated further, and future scope is to complete this digitalization of this for other regions also. These are the references I followed.
Okay.
Thank you.
Thank you. May I know the intuition of this paper? What makes you to think about this paper?
There actually there is no unified and platform for toy and game, specifically for toy and game. So, and India is a rich cultural heritage of toys and games also for in different other regions. So, this motivated us to think of this stuff.
Okay, so in your application, how many different kinds of toys that you have designed or taken into consideration?
Yes, sir.
In your paper, how many
Yes.
different kinds of toys that you have addressed?
Sir, I have addressed this in categories
Mm-hmm.
like historically, regionally, and material-based toys which are there.
Okay, so in total, how many kinds?
Sir, I think more than 100 kinds. So I'm sorry, I'll interrupt. So this is her
No, please.
This is her PhD topic area, actually, Toys and Games of India. And this was objective one, where she has to put in the entire history and contemporary toys and games into one website, and also explore the virtual reality and immersive media applications. So these were the exploratory initial phases of her PhD research. So more than 100 toys, sir, like Channapatna toys from Andhra Pradesh, wooden toys, metal-based toys, paper-based toys. So more than 100 kinds of toys from every state of India has its own traditional toys, historical toys, and contemporary toys. And toys are different from games. So she's trying to put everything, all that information together in one website, and she will also publish a book later on as part of that. So that is her objective one only of her PhD.
Great, man. Great.
Yeah.
Do you have any working models
of this prototype? Yeah, she has given a link. Ruxana, is it possible for you to open the Figma link? It is easier to show the Figma link than the VR wala.
Correct.
Okay, ma'am. I'm sure.
So just give
Since you
us.
might have worked a lot on this.
Yeah. So just give us
just
1
wanted
minute.
to have a glance of it, how beautiful it is. Oh, nice.
Yeah.
Okay.
So this is the home page. Is it visible?
Yes, very much. Yeah.
So this is the home page, and there are various categories: historical, regional, material-based,
Can you click on any one link?
Yeah, historical evolution. This one is the historical evolution, and there are Indus Valley, Vedic era, medieval, Mughal. Then we will find
It's
this.
going to give the information about it, correct?
Yes.
Yes.
So these are from government websites only, because recently the government was doing a lot of toycathons. So we collected data from various government initiatives, mostly also from some books that we have from National Institute of Design, Ahmedabad. They have a few books on traditional toys and games of India. Few information is from there. So yeah, that's how.
Great. Nice work. Keep it up. All the best.
Thank
you.
you so much, sir. Thank you.
Thank you, sir.
Thank you so much for such an interesting presentation.
Thank
you. As we head to the end of this session, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We'll be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair for chairing this session with such great enthusiasm. As a token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners, I would now like to invite Sir if you could please deliver a few closing remarks.
Once again, thank you for giving me this wonderful opportunity. As I informed you in the beginning, it is always a wonderful experience to be part of this conference where we will get an ample kind of opportunity to listen to the very good authors in diversified domains. So if you look at all the papers that what I have shared today, which is covering more than 7 to 8 tracks, around 10 papers. So it is not only a kind of informative for the authors, but also equally gaining experience knowledge for me. So once again, I would like to thank the organizers giving me this wonderful opportunity, keep accepting me as a session chair. So I wish you all the best. Looking forward in the future endeavors to collaborate with you with the same efforts. Thank you once again.
Thank you so much, sir. Thank you for your guidance. And thank you, everyone, for your valuable presence. I kindly request you all to switch on your cameras for a quick snapshot of this virtual conference. Everyone smile, please. Okay. Thank you so much, everyone. Stay safe, stay healthy.
Thank you. Bye.
Thank you. Bye-bye.